All right, in this video, I'm going to look at slope. Many of you joined me for class. Some of you joined me when I had to do the class remotely on Thursday, but I thought I would go ahead and just do a video on this since you'll be working on this over break and it might be helpful. Okay, so the first page just were problems that I wanted you to graph and bring to class. So it didn't involve slope yet. You just wound up finding some ordered pairs and getting the lines graphed, and this is what they should look like, okay? All right, but then we're going to come back and we're going to talk about this concept of slope. And so I'm going to go to a whiteboard for just a minute to remind you of a few things about, or to give you an idea of what slope really is. All right, so remember that, go here. All right, so do you remember at the very beginning of class, that problem I keep using? Okay, that was like the cost of a plan for renting movies. And the one company, I think it was Net Movies, charged $13 flat fee and then $2 per movie. And we could go in here and we could find ordered pairs. Oops, it's not X's and Y's. I was using M's and C's. So like if I rented no movies, I'd still owe a $13 flat fee. And if I rented 5 movies, I'd have to pay $10 for the movies plus the 13, which would be 23. And that would be the monthly cost. So in a month, if I rented 5 movies that month, I'd owe $23. All right, we could do others. And so then we could sketch the graph of that situation. So we'd be up here at 13, and then when we're at 0, and then when we're out here at 5, we'd be up to 23. And this line right here is where all the ordered pairs that would satisfy that equation would fall. Okay. All right, but the thing that gets at the slope is that, if I'd rented one, let me move the 523 out of the way for a minute. So if I signed up for this plan and then some month I didn't rent any movies, I'd still owe $13. If I rented 1, I'd owe 13 plus 2. If I rented 2, I'd owe 13 plus 4, or I'd owe another 2. This idea that as I rent one more movie, the cost goes up by $2. Okay, one more movie, the cost goes up by $2. All right, that $2 per movie, that's the slope. So this right here, this is telling you that that line is increasing. The cost goes up, increases by $2 per movie rented. And so the slope, which we use an M, you'll see that later, would equal the $2 per one movie. The slope would really be 2. But it's really the rate at which cost is going up, the rate at which the cost is changing, okay? It's really a rate of change. We talk a lot about that in later classes, but it doesn't hurt to have a sense of what the slope is and why it's so important, okay? All right, so now let's go to the page where we're actually doing the notes on slope. No, let's go ahead and start with this. All right, so what I've talked about is that slope, let's see if I can get all 3 of these on one picture. Okay, so slope is really the change in the y over the change in the x. It's the rate of change in your y divided by the rate of change in your, or divided by the change in your x, okay? All right, so basically I want you to think of it like this. If I want the slope of that line, M later is going to be used for that. So I'm just going to start doing that now. So the slope when you're doing it from a graph, you can think of it as just rise over run, you know. So what you're going to do is you're going to begin, find a starting point, and then you're going to think about the directions it would take to get from that starting point to where you're trying to get to. So those are 2 points that I might use because they're right on nice tick marks and they're easy to see. And so you can really just count. That's what you should do. No formula, just count. So see how the change in the y, you would go down 4. That's negative direction, 4 units. And then it looks like you would go over 1, 2. So this right here would be to the right 2. And the rise over the run turns out to be negative 2. That's going to be the slope. Okay. So slope is a number and it's associated with the line, and it's supposed to indicate to you whether the line is going up or going down. And it's also supposed to give you a sense of how steep or flat the line is. All right, so this next one, we could do the counting. So remember or think about slope. Slope is really this same idea. Let me go back to the whiteboard a minute. The slope is really this idea that as I go up one movie, the cost goes up too. Okay. So, I mean, as I rent an additional movie, the cost goes up too. So it's going to go up $2 for every one movie, up $2 for every one movie, up $2 for every one movie, and so on. That little stair step look is what I associate with slope. Okay. Now let me find where I want to be on this guy. Okay. So when I'm doing this one, I like to pick points that are kind of far apart. It's easier for me to think about them. So as I look at that, see this point was right here at the -5 on the y, and I'm trying to get to this point over here. So it's like this is my home and this is my friend's house. I would have to go up 1, 2, 3, 4, 5, 6 blocks, up 6, and then I'd have to go over, oh, that turns out to also be 6 to the right. So that would mean the slope would be 6 over 6, which is 1. Okay. All right, and then when you look at this guy and you think about maybe my home is here and I'm trying to get there. Maybe I'm over here at -1 and I'm trying to get over here to 2. I'd have to go to the right some amount. So if I was at -1 trying to go to 2, I'd have to go 1, 2, 3 units to the right is all. But see how there's no units up or down? So if I were going to do the slope of this, the rise is 0. The run depends on which points you use and which direction you're going. But in my case, I started here and went that way 3 units, but that reduces, simplifies to be 0. So my rise over run would be 0. Okay. All right, so let's kind of formalize. Let's do a little notes on slope here, and then we'll look at how to do the slope. What are we going to do when we're given an equation? And then what are we going to do if we're given 2 points, etc. So this is kind of the big notes page. So let's take a look at it. Excuse me. All right, so let me grab that. Okay, so again, most of you have seen this, but some of you were having trouble with your connection, and I thought others might be interested in just reviewing it since it's so important. All right, so slope is this concept, and we use an M for slope. That has to do with some French word that was that stands for that. And slope is this number that we associate with the line. So there's a line only has one slope. You know, it's this number that you associate with the line. And what it does is indicates the steepness and whether it is rising or falling. Okay. And when you're thinking about the slope is going to be a number, you know, so the slope we might say is 5, but I want you to consider both the sign of it. So separate that from the number part, from the size of it, because they tell you different things. Okay, so you've got the sign of the slope, And then you've got the size of the slope, which is really getting at like the number part and what it tells you. Okay. So first, just the sign of it, like if it's positive or negative, right? You're going to read the line like you do a book from left to right. You know how you read from left to right? That's how you should look at these lines. And you see here how this line, as you look from left to right, is going up. Okay, that's going to have a positive slope. The line is rising. Okay, more formally, we would say it's increasing. Okay, it's increasing. The function is increasing. The line is rising versus this line, as from left to right, is falling. Think of it like the cost going up, cost going down. Okay, more formally, that would be called decreasing. Okay, and it would have a negative slope because you're going down. All right, and then these are the two special cases. So this one right here, as you go from your home to some other place, you don't have to go up or down at all. You just have to go to the right. So if you're thinking rise over run, so if you're thinking this, there's no rise. There's no change in the y's. There's no rise change. So it would be 0 over some number. So this one right here always has a slope of 0. And this guy, on this one, the run would be 0 because you don't go left or right. So this one will have some number, but then it'll be divided, some number on top. I'm not trying to indicate a particular one, just some number, and it'll be divided by 0. So this one doesn't exist because you'll get an error, won't you, on your calculator? So this one, M, is undefined. Try to avoid using the no slope concept because we'll both be unclear about whether you mean 0 or undefined. So just say this one, the horizontal one, has a slope of 0. The vertical one, the slope is undefined. Okay. All right, now when you're looking at I want you to just think about it like a hiking trail. Going up the mountain is positive. Going down the mountain is negative. When you're walking on a trail like this, it's no effort. There's no elevation change. So it's really nice and easy to do the walk. That one has a slope of 0. When you look at this guy, you could not walk up that, right? So you can't walk on this. You could climb it, but because that's the one that's impossible to walk up, that's the one that's undefined, okay? The one that's really easy, no effort, that's the one that has the slope of 0, okay? So positive slope, negative slope, 0 slope, and that one's undefined. That's what the sign of the slope tells you. All right, now I want to focus on what does the number part tell you? And so let me just kind of show you something before we just put it in there. So here's something to think about. All right, so let me show you some things. So if the scale were the same on both axes, this line right here would have a slope of 1. And a line with a slope of 2, think of 1 as $1 per movie. Slope of 2 is $2 per movie. So wouldn't that mean the cost would be greater, rising more rapidly? That's what I should have said. And if M was 3, the movies cost $3 each, it'd be even steeper. Okay, see that? And if the movies cost $10 each, which by the way, some of the movies on my cable, it shocked me one time because I rented a movie without really paying attention to the price, expecting it to be like it normally is, which is around $6, and it was $19.99. So be careful. Anyway, that one might be like a slope of 10, really steep. So see, as the slope number gets bigger and bigger and bigger, the line, can you see that? Looks like it's getting steeper and steeper. And like a line right here still has a positive slope because see how the line is rising, but it might have a slope of 1/2. All right, then if you considered what would a -3 slope look like? Okay, it would look something like that. By the way, they don't all have to go through the origin. They could be oriented anywhere in the coordinate plane, but I'm just doing that for this business. So I didn't do a very good job. I was trying to make the angle here the same. So a slope of -3 would have to have the same steepness, the same amount of verticalness. The negative would just mean that the line is falling. The fact the 3 is the same means those should be similar in steepness. And like a -1, if this is 1/2, a -1/2 should be like that. Again, it's hard for me to draw it, but I'm trying to make it where this angle is the same. That would have a slope of -1/2. So the number part tells you how steep it is or how flat it is. And the sign tells you whether the line is going up from left to right or going down. All right, now let's consider the x and the y-axis themselves, or lines that are horizontal and vertical. See, as you look this way, how the numbers are getting smaller and smaller and smaller? Well, the x-axis would actually have a slope of 0. It's the ultimate in flatness, okay? And when you look at things this way, the numbers are getting bigger and bigger and bigger. It's like this one right here, I almost want to say is infinity. And it kind of is, but we say it has an undefined slope. That's the one you can't walk up, but it is really basically infinity slope, okay? All right, so negative slopes have to fall, positive slopes rise. The bigger the number part, the steeper the line, okay? And so if one is -3 and the other is 3, they're still going to be the same steepness. It's just one's falling and one's rising. Okay, think about that because that'll help you a lot. All right, let's go back and let me look at this part, filling in the size of the slope. This absolute value of m is really just telling you to ignore the sign and look at just the number part. So don't worry about whether it's positive or negative. It's absolute value of your slope. That's just a way of taking the sign of the slope out of the picture and looking only at the number part. So the greater the number part, the steeper the line. Okay? All right. Now, here in the middle, this activity I like to do before you start trying to use any kind of a formula to give you, again, a better intuition about slope. All right, so let me explain the problem. So what we've got are 3 lines named line 1, line 2, and line 3. And I wound up giving you some possible slope values. And these are the only numbers you can choose, those slope values. Okay. And I did put the lines on the same coordinate plane, so the same scale is being used for all 3 lines, but I didn't put the tick marks because I purposefully do not want you counting or using any other way of getting slope, okay? So here's how you can think about this. Okay, look at line 3 first because that's the one you can kind of get out of the way. See how it's a special line? And so this line is perfectly up and down, vertical. So think about the hiking trail. You can't climb up that, so that line is going to have an undefined slope. That would be line 3. Okay, the slope is undefined there. Okay, line 3, the slope is undefined. All right, so that one's out of the way. Now, with line 1 and line 2, you might be really like wondering how in the world are you supposed to be able to do that? Well, what you do here is you first just look at how line 1 is falling, decreasing as you read it from left to right. So you know the slope has to be negative. And look at how line 2 goes up. So it's positive. So then here's the issue though. when I look at my options, I've got two positive numbers to choose from. And if there was not another line on that coordinate plane other than line 2, it could have a slope of 3 or it could have a slope of 1/2 because I haven't indicated what the scale is there. So how you decide which one of those to pick is you also look at how relative to one another, how steep they are relative to one another. So see how line 2 is more vertical than line 1. Line 2 is steeper. Line 1 is flatter. So you would have a problem if you decided to pick 1/2 for the slope of line 2, you'd have to have a smaller number to use for the number part on line 1 because it's flatter. And there isn't a number part smaller than 1/2. So that means you can't use that there. This one would have to have the biggest number part. So you'd make it positive 3. And then this guy has to be negative and the smaller number part. So it would be negative 1/2. So line 2, we said had a slope of 3. So that's C. And line 1 had a slope of negative 1/2. Okay. So line 1, m equals negative 1/2. Line 2, m equals positive 3. And line 3, m is undefined. Okay. So that activity is supposed to get you to really think about the relative steepness of the lines and whether they're rising or falling rather than always having to do a formula. Okay. All right, now down here at the bottom, we're looking at what most people think about when they hear the word slope. They think, oh, that's that formula, you know, that y2, y1 thing. All right, so let me make sure you understand what the formula is saying. Okay, so again, we're working on slope. We have this line over here, and I just identified a couple points on the line. And then I'm not specifying specific numbers to use as the coordinates of the point. I've got like x1, y1, because this point could be, you know, varieties of things. And this one I called x2, y2. Now, let me make sure you understand these subscripts, okay? Using subscripts, a 1 down low like that or a 2 down low like that, that does not mean to square what's there. It's just a name, okay? Just part of the name. But it's kind of like a number on the back of a jersey, okay? So if you have a 3 on your jersey, and you're a Pirate, say, and you have a 3 on your jersey, and then some other player who plays for us has a 10 on their jersey. They're different players, but they're on the same team. So what I'm trying to indicate here is that these are both x coordinates, but this one comes from the first point and that one comes from the second. And you know how every point is some x followed by some y. So that's why there's always an x and a y on it, okay? All right, so now when we've worked a little bit with slope, but we've used primarily rise over run. And rise is just an easy way to talk about thinking about what the change is vertically. So the change in your y coordinates, the change up and down, right? That's what that is. How far up or down did you go? And the change in the x coordinates is how far right or left you went. That's what the run would mean. And really, that's what I think of when I do any problem. But the formula comes from this. So like if I'm trying to go from this point to that point. So if I'm trying to, this is my home and I'm trying to get to the second point. And I want to tell somebody the directions for getting there, I would tell them you do that in the vertical direction and do that in the horizontal direction. And so this y and that y, if I subtracted them, would give me the change in the y's. And then if I took this x, subtracted that x, that would give me the change in the x's. That's where that formula comes from. But the formula and the subscripts are really just trying to make sure you understand that slope is the change in y over change in x, and that the difference in the y's is on top. Okay, I should not see x coordinates on top of the fraction. And then the subscripts are trying to tell you, really doesn't matter which point you consider the first or the second point. The subscripts just try to tell you that to be sure to subtract in the same order. Okay. All right, so let me show you what I mean. So here's an example. This says, find the slope of the line passing through each pair of points or state that the slope is undefined. Okay, so here I don't have a graph or anything like that. If I'm given 2 points, probably the best thing to do is to think of the formula, think of the change in y over change in x. But normally what I do is this. I just know I need to subtract my y coordinates. Now, some of you might have been saying, yeah, but I would have called this point, I would have had that as my first point, and I would have started with the 1. Okay, you can do either of those are correct. Okay, it doesn't matter which point you're really considering. I would highly recommend you not start trying to label x1 and all of that, because people do things like x1, x2 when it's really x1, y1, and then x2, y2. Get it all messed up. So just remember, change in the y coordinates are on top. And the subtraction is because you're looking at the change. So it's always a minus. That's part of the formula, right? And then you just put your y coordinates. Now, if you did -4 minus 1, the subscripts are reminding you that what you put here has to come from the same point, what you put in the beginning. So if you started with the y of -4 and subtracted 1, you'd have to start with an x of 3 and subtract -2. Okay? But the other one would also have been correct. You would have just started with the -2 and subtracted the 3. So if you did it the first way, you would have the -5 on top and a +5 on the bottom. If you did it the second way, you'd have a +5 on top and a -5 on the bottom, but either way, it's going to reduce to be -1, simplify to be -1. So the slope of the line turned out to be -1. Now, something I recommend you do is a quick sketch of the points. Don't put tick marks. You don't have time to do that, but 3, -4 would be somewhere over here. -2, 1 would be somewhere here. And when I look at it, I can see that line is falling. So if it's falling, it should have a negative slope. And that way you might not mess up on at least that part of it. It's a common mistake to have the numbers right, but have the sign incorrect because you don't pay attention to subtracting in the same order sometimes. So here's what you want to check. Are these y's? And do these come from the same point? That's what I do when I'm trying to do a quick check as I'm walking around the room. I look, did you put the y's on top? And did you start from the same point? Okay. All right, so let's look at number 3 now. So we're going to set it up. I'm going to subtract our y coordinates either that way or that way. And when I go back to subtract my x's, if I was doing 2 minus 5, I would have started with this. Oh, but then the other one's also -4. And see, by doing -4 minus -4, there's been no change in the x's. So you're going to get a 0 in the denominator. Some of you might have had -3, some might have 3, but either way, slope is undefined. Because you can't divide by 0, you'll get that error message. This gives you an error when you do it on your calculator, okay? Because division by 0 is undefined. Okay, so this was a special case. Watch why that happened. -4,2 would be here, and -4,5 would be above it. And the line that we're talking about is vertical. You can't walk up that. The slope is undefined. Okay? So that second page is really the key kind of notes. And then what I'm doing on the rest of this is, let's just kind of glance. Sometimes you'll have a graph. Sometimes you'll have 2 points. and you'll have to find the slope. And then sometimes you have an equation, you have to find the slope, okay? So let's do one graph. I'll do number 4. All right, so I'm going to pick one of these. Let me do number 6. It's a little harder. Let me do this one. Okay. And then we'll do one where we got 2 points because we've tried each of those. Okay. All right, so if I've got the graph, then the way you should be thinking about it is just rise over run. Okay, I normally recommend you pick the point furthest to the left just to have a consistent approach. Okay. And then what you would do from here is you would count to get to this, how far down and how far, what do you have to do? So from here, you'd have to go down 1, 2, 3, 4, and then another 8. I usually kind of count it in pieces, like to here is down 4, and then I go down 8 more. So it's really, I went down 12. But this one's kind of hard, and I wanted to show how sometimes I count to the x-axis, and then I keep going. I wouldn't recommend you identify the coordinates of the point because a lot of times you'll have the wrong sign on it, or you don't identify the coordinates, you don't put them in the right order, and so your slope's all messed up. So try to do it just by counting. And then I would go to the right, what appears to be 1, 2, 3 units, so that's positive 3. So my slope would be down 12, right 3. That would turn out to be negative 4. Okay. All right, now I used the 2 bold points because they made they made them so obvious. But watch. Doesn't matter which way you move. Like somebody might have done the same thing, but instead of going from the leftmost point, they might have started there and gone up 12 and to the left 3. Well, if they had gone up 12 and left 3, it still simplifies to be negative 4. So that would have been okay. So it doesn't matter which 2 points, and it doesn't matter which point you start with and how you finish. Okay, now let me look at another one. Another possibility. Somebody might have gone maybe just to there, gone down 4 and to the right 1, and then down 4, right 1 would equal negative 4. So it really doesn't matter. But that's a little dangerous if they haven't made the point bold because, you really need to be sure of what they're trying to indicate it, so that would work. And this would also work. I could go up 8 and I could go to the left 2. See how all of those really turn into the same thing. So any 2 points on the line you look at, when you calculate the slope, you're going to get the same thing because slope is constant. When you have a linear equation, the slope is always the same. Okay. All right, now I want to go back to the sheet. I want to move to the problems where you've got 2 points. And let's do one of these. Let's do number 8. Okay. All right, so if we look at number 8, you're just using this one. I'm going to still think rise over run, but I'm kind of thinking more of change in y over change in x. More than anything, I'm kind of thinking change in my y's over the change in my x's. Okay, so when I set up my formula, I got to be sure that I use y coordinates on top. And you could have done 5 minus negative 2. That's still y coordinates. The minus is part of the fact you're changing. Then in the denominator, I would have negative 3 minus 9. Over here, I would have had to start with the 9 and take away the minus 3. All right, so on the first one, you would have the negative 7 on top, negative 12 on the bottom. If you did it the second way, it would be 7 over 12, but these are equal because a negative divided by a negative really is 7/12. So the slope would be 7/12. Okay. So that's like you go up 7 for every 12 you go in the horizontal direction to the right. Okay. All right, so now I want to do these 4, and then we'll go back and we'll fill in the rest. So this is different than anything we've talked about right here. These last 4, I'm asking to get the slope of the line from an equation, okay, rather than 2 points or rather than a graph. And you don't want to take the time to graph it. So the thing you're going to use for that is you're going to think about how y equals mx plus b is a form of an equation called the slope-intercept form. And we're just trying to get slope. So that's the m, isn't it? So if we have an equation in this form, we can just look at the number that's the coefficient of x, and that's going to be your slope. Okay? So on this one, it's already in slope-intercept form. Let me just write it a little bigger so I can circle that. So the slope is 3. M equals 3, and that's all there is to it. Not 3x. Slope is the number in front of the x connected to it. Okay, and watch it. Sometimes they'll like give you an equation and it might be in this order, 2 plus 3x. The slope isn't 2. The slope is the number in front of the x, what's connected to the x, but only if the y is on a side by itself. So make sure it's on a side by itself first. Okay, now this equation, number 11, this is in standard form. ax plus by equals c is called the standard form. This is the point intercept. Wait, let me start over. I'm getting tired. That is the slope intercept form. And so it tells you the slope. This one is just called the standard form, and you don't get anything out of it directly. But remember that section in 2.5 where you could solve things like this for y. So that's what we wind up doing here. Okay, so on problem number 11, I'm going to say, wait a minute, the slope is not, m is not 3. It's not just the number in front of x because the equation is not in slope-intercept form. So you have to rearrange things and get y by itself. So you'll start by subtracting the 3x from both sides to get rid of that. Don't lose that negative right there. A lot of mistakes come from dropping that negative. So this is negative 3x plus 9. Okay, and then in between those two is multiplication. So I need to get rid of that. I do that by dividing by negative 2. And when I do, I'm dividing the right side by negative 2, but it gets distributed. So I really did this. But then that negative 2 is like having a negative 1/2 being multiplied. It gets distributed. You don't do all of that. You usually just show it the way I did right here. But I just want to explain. It's not that I divided by negative 2 twice on the right. I divided once, but then I had to use the distributive property. All right, so then that gives me 1y or y. This gives me 3/2 x. Positive 9, negative 2 would be minus 9/2. I don't care about the 9/2 though, because I'm just trying to do slope, and that's whatever the number is connected to the x. If you've got it, so it's in slope-intercept form. Okay, so the slope is 3/2. Okay. And then how I want you to think about 12 and 13 is I want you to visualize them. All right, when you're looking at y equal 4, that's just telling you all the y's are 4. All the y's are 4. So that means no matter what, you're going to be up at 4 right here. You always go up 4, so you're going to be somewhere on that line. And can't you walk on that? But there's no effort. So the slope of that line would be 0. Where with x equal negative 10, that's telling you all the x's are negative 10. That means you're always going to be over here at negative 10 no matter what. Okay. You're always going to go to the left 10. So you'll be up or down there. and you can't walk up that. So m is undefined on that situation. And it is true that any y equals a number, so if y equals some number, or if x equals some number, those are special cases. The x equal is going to have an undefined slope, and the y equals is going to have a zero slope, but only when they're the special kind where you don't see both the x and the y. Okay. Now, what you should do is pause the video and go back and finish the rest of the questions on this sheet, and then check to see that you got the same thing I did. Okay. So I'm going to go do it now, but you should pause the video, do it yourself, and then check. Okay, so I'm going to go back to the 2 points, number 7 and number 9, that I didn't finish earlier. And let me finish those kind of now, and you can just check your work. So I've got 2 points. So the slope, I'm just going to subtract my y coordinates. And if I decided to do 7 minus 3, I need to start with 9 and do 9 minus 8. I get 4 over 1, which is 4. If you had done 3 minus 7, you would have had to have done 8 minus 9, negative 4 over negative 1, also 4. The slope is 4. Okay. And when you look at number 9 and you set it up, change in the y's, you might have done, I don't need the parenthesis on that, you might have done negative 4 minus 3. When you do the change in your x's, you come back to the point where the y was negative 4, but you're going to have negative 7 minus negative 7. So it's negative 7 on the top, but down here, that's going to turn out to be 0. This is the one that gives you an error. So the slope is undefined. Okay. All right, and then let's just finish. Let me go back to previous snip where we were doing the graphs, and I'll do the slope of the other two by counting. Okay. So on question number 4, you should just think rise over run. I like to start with the leftmost point, and I can see I would have to go up 2, that's positive 2, and to the right 6 units. So it's positive 2 over positive 6, which would be 1/3 when you simplify it. And notice that's positive, and the line is rising. So positive. Make sure that matches. All right, and number 5, to go from this point to that point, the slope is that you don't have to go up at all, right? So the rise is 0. And then if I started with this point over here, it would be negative 2 plus 5. That would be over 7 that way. But up 0 and then over 7. You might have gone in the other direction, had 0 over negative 7. But 0 on top divided by 7 does exist. It's equal to 0. So m would be 0. Don't put undefined. M would be 0. Okay, so that's a discussion about the slope of a line. Okay. All right, so let me go ahead and get that posted.